Hello, my name is Trent Kalman, and today I'm going to be discussing time dilation. If you have seen a science fiction movie, such as Interstellar, that includes scenes where there are people traveling near black holes or at the speed of light, you might be somewhat familiar with the term time dilation. Essentially, what needs to be understood for time dilation is Albert Einstein's theory of relativity. This theory states that regardless of where you are in the universe, the laws of physics will always be constant, and the speed of light will also be constant. So this means anywhere you see a photon moving in the universe, it's always going to be traveling at approximately 300 million meters per second. Although it can be pretty difficult to explain exactly how time dilation works, a good way is to show a clock that can be seen here. This clock uses two mirrors that shoot a photon between each mirror, and the time it takes for this photon to bounce between the mirrors can be measured at a specific time interval. If we put these clocks out in space, and we have one clock that is stationary and another clock that is moving, it can be seen that the stationary clock is going to be operating normally. So each time you see the photon moving, it's going to be at a specific time interval. However, if you look here, as the other clock is moving, the photon is actually traveling a farther distance to someone observing. This is because as the clock is moving, the photon is shot down to the bottom, and by the time it reaches the top mirror has actually been displaced. So if you're seeing this as an observer, you're going to see that the photon traveled a farther distance. And because of how I stated earlier, the theory of relativity states that the photon is going to be traveling at the same speed, but since one photon is traveling a farther distance, someone observing these two clocks is actually going to see that the time interval for the clock that is moving is actually slower than the clock that is stationary. So essentially, this observation is what is defined as time dilation. And even more interesting than that is there's been studies on how gravity can affect these times. And at certain areas in space, such as really close to black holes, time practically does not move. But that's a whole different topic. Anyways, I hope you enjoyed this video and that you learned something. Thank you for your time.
Created using Powtoon.